our session. So given function f, which is continuous, and we know several values of our function. In particular, our function at -2 is 4. At f0, it is -2. We know that at f3, it's 6. And we know that our function is monotonic from -3 to -2. Okay, we'll discuss about this. It's monotonic from -2 to 0. For sure, our function from -2 to 0, since it's monotonic, it's going to be monotonically decreasing. And also from 0 to 3, we know that it is going to be increasing, somehow like this. Okay. And we know that from -3 to -2, our function is again monotonic, but now we don't know it is monotonic increasing or decreasing. We have to get some ideas about f of x equals to 0, about the equation f(x) equals to 0. And we are given 5 statements. We have to find the correct one. It says our function has at most one solution. Definitely this is wrong, because we have, according to IVT, intermediate value theorem, we have already found at least 2 zeros, right? Am I right that we can say we have from -2 to 0 at least one solution? Is this correct?
Yes.
Can we have more than 1 zeros?
No,
Why not?
because it's decreasing only.
Right.
So it's going to hit 0 once.
So it's monotonic. So if it is monotonic, it intersects. One thing that I do not like at this point, we have here f is monotonic without saying strictly monotonic. So in theory, I'm not sure it is the case, but maybe our function is decreasing, but not strictly decreasing. It decreases like this, then a lot of zeros, and then continues to 0. So, but I hope, let's keep this in our mind and move forward. Exactly 2 solutions. Can we say that this is also not correct, as from -3 to -2, we don't know what's happening with our function? What if it decreases like this? We know that it is monotonic, but monotonic increasing or decreasing is not given. So saying it has exactly 2 solutions also is wrong. At least 3 solutions. Again, this statement is not in general correct. What if our function from -3 to -2 is not decreasing but increasing, or it decreases but like this without having any zeros? So at least 3 solutions also is not correct. At most 3 solutions, and at most 2 solutions. At most 2 solutions we can drop, because what if we have another solution here? So it remains at most 3 solutions, the correct answer. And here, the monotonic that I said, maybe it is not strictly decreasing. It should be somewhere added, is missing here. So we have to say it's not monotonic, but it is strictly monotonic. Then everything is much better. Questions?
So the outcome of our exercise is the same in case it's strictly monotonic or just monotonic, or
In this case, yes, the formulation I think is not the best. Here we are missing the strictly monotonic word. But the rest, A, B, C, E, we can eliminate even if our function is not strictly monotonic or it is monotonic, or definitely we cannot say, for example, that it has at most two solutions, because from -3 to -2, our function can be decreasing, having another zero. So it might have three solutions. At least three solutions also might be wrong. Exactly two solutions, at most one. All this we can easily eliminate, and it remains at most three solutions.
All right, thank you.
Other questions? If no, let's move forward to the next question, which is number 6 from the same year. We have graph of the function of f prime. Guys, please be careful. Often we are not reading our exercises correctly, and we are missing some very important condition, like this is not graph of f, this is graph of f prime. Which of the following is true? So this is graph of function f prime, and statement A says f has one minimum and two maximum points on AB interval. How we can understand the number of minimum maximum points knowing what is the derivative of our function? The way is, as always, find critical points and then study whether the sign of derivative is changing passing through this critical points. So, do you agree that zeros of our derivative are critical points? So, we have 4 critical points. Next is to understand the sign of derivative on each of these intervals. So, from A to the first critical point, our derivative is positive. So let's put plus sign here. Then negative, negative, positive, and once again negative at the end. And pay your attention, AB interval is given open, so endpoints we are not going to consider as minimum or maximum points. In this case, let's discuss the first critical point. From positive to negative, function increasing then decreasing. What is the first point?
Maximum point?
It's a maximum point, exactly. Second critical point, this one. Maximum or minimum?
It's not an extremum point.
Exactly, because the sign of our derivative is not changed. So it's on both sides negative, so second critical point is not an extrema point. Third point is what?
Minimum point.
Minimum. And what about the last one?
Last is maximum.
Maximum. So we have 2 max and 1 minimum. F has 1 minimum, 2 maximum. Seems to be correct. F has 3 minimum. We have only 1 minimum. Yeah, so we have this. Correct answer. Okay, once again, from the graph of derivative, we can understand the sign of derivative and zeros of derivative. I have another question. Do we have points where function is not differentiable?
Is this a king point?
So let's call this x2. x2, at x2, function is differentiable or not? What do you think?
It is, but maybe it's an inflection point.
Inflection point or not, we can discuss. But there's a graph of function of f prime, right? And this graph of f prime is well defined. So function is well defined at any point from A to B. So function is differentiable on AB interval. At every point, it is well defined. But at x2, second order derivative of our function doesn't exist. It's a king point for f prime, so f double prime doesn't exist at point x2. You said inflection point. How from the graph of f prime we can find inflection points, guys? So it's a graph of f prime, not f. The graph of f prime. How we can understand which points are inflection points of function f?
We should find the points where we should find the I forgot the word, the maximums and the minimums
Yes,
of the
maximum and
critical
minimums.
points. Yeah.
Extrema points of, so here we have minimum point, maximum point, minimum point, maximum point. All these 4 points that are extrema points for f prime, extrema points for f prime are inflection points for function f as well. So we have 4 inflection points, but we have only 1 minimum and 2 maximum points. Okay. Let's move forward. Next question. Same year, multiple choice number 10. Okay. We are given function f defined everywhere and satisfies the following conditions. Derivative at 1 is 2 and function f is concave up. Okay. What can we say about given statement? Which one is true? So we know that function is concave up. What does it mean? Function to be concave up. We have, first of all, definition of concavity. Concave up, I'm just writing information and then we will discuss about given statements. So we have definition f alpha x plus 1 minus alpha y is less or equal than alpha f of x plus 1 minus alpha fy. This is the definition. Is this property needed here? Maybe. Who knows? At the first glance, no, but yeah. We have some information about f prime. If function is concave up, what can we say about derivative of our function? If f is concave up,
It should increase.
f is an increasing function. Because double derivative as non-negative means f prime itself is an increasing function. Okay, which of the following should be true? F prime at 3 is less than 2. Should it be true?
No, it should increase.
At 1, it is 2. At 3, it should be not smaller than 2, definitely not smaller. And here we have exactly smaller than 2. Of course, this is not true. At -1, so on the left-hand side of 1, since function is increasing, f prime is increasing, on the left side, we should get smaller values than 2, not bigger values. So A and B contradict to the monotonicity of f prime to being increasing function. F3 minus f1, f1 minus f minus 1. So do you have any clue about CDE, about which topic it could be?
Mean value theorem.
What says mean value theorem? Like f3 minus f at 1 divided by 3 minus 1 is derivative for our function at some point c, where c is from 1 to 3. Okay. And we said just derivative of our function is increasing. So what can we say about f prime c? F prime.
It should be
Yeah,
bigger than 2.
it should be bigger than 2. Because c is greater than 1. Derivative is increasing, so it gets bigger than 2. F3 minus F1 is bigger than 4, not smaller than. So this being smaller, again, we can drop. Huh? What says statement D? Again, mean value theorem. F1 minus F minus 1 divided by 1 minus minus 1 is F prime at another point C1. Now this C1 is smaller than 1, hence derivative should be less than 2. Again, this is not correct sign of inequality. We can drop this. And for the last one, hopefully it is the correct statement. Let's check. F1 minus F minus 2 divided by 1 minus minus 2. So 3 is less than 3. Sorry, less than 2. Why 2? Because at 1, derivative is 2. On the left side of 1, derivative should be smaller than 2. Function is increasing. Multiplying by 3 we'll get this statement. Questions here? Everything is fine in this proof, or? Again, what I do not like here, f is concave up, which means our f prime is increasing, but again, not strictly increasing. If it is not strictly increasing, equality might happen. And here we can get not strictly less than 2, but smaller or equal than 2. So in my opinion, again, having here strictly concave up would make this exercise better. Statements from A to D are obviously wrong. We are dropping them out. Statement D, yeah, correct, but let's add strictly concave up to have smaller or equal, not just strictly smaller. Do you agree with this? I hope so. Questions? No, let's move to the next question. Again, from the same test. No, not from the same test. We are done with this test. Let's move to 2021. Okay. Show work number 1 and 3. Find the equation of the tangent line to the curve at point x0. Okay. First, can you remind me the equation of tangent line?
F prime
x0 minus times x minus x0 plus fx0.
F prime x0 times x minus x0 plus fx0. Okay. To find the equation of tangent line, we have to calculate slope and value of our function. In this exercise, our function f is not given explicitly. So we have implicit function here given. And that's fine. We can find tangent lines to some curves, even if curves are given through implicit equations, implicit functions. Still, we have to identify the derivative of our function at x0 equals to 0, and we have to calculate value of our function at x0. Let's begin with the value of our function. Function is y. So what is y? X0. What is y at 0? To calculate this, we have to use our equation. Let's call this equation asterisk and plug x equals to 0 into this one. Okay, what we'll get? Y cubed at 0 plus 0 squared times arctangent, which is 0, plus e to the power of 0 equals to 9. This gives y cubed at 0 is 8. Hence, y at 0 is 2. Right? It's 2. Next is to calculate derivative of our y. So let's take derivative of equation, whole equation. Derivative of y cubed gives 3 times y squared times y prime. Remember, y is a function of x. Second term, product of two functions. And the formula for the derivative of multiplication says the derivative is 2x times arc tangent x plus x squared multiplied with the derivative of arctangent. Remind me what is derivative of arctangent?
1 over 1 plus x squared.
Thank you. Okay, and the last term, derivative of exponential x times y. So derivative of exponential function is itself. And chain rule says we have to multiply with the derivative of power, which is product. So derivative of x is just y. And plus x times y prime x. Equals to what?
0.
Derivative of 9 is 0. Plug x equals to 0. What we'll get? Plug x equals to 0, we'll get 3 times y squared. Y0 we just calculated, it is 2. So we'll get 3 times 2 squared times y prime. 3 times 4 times y prime at 0. X arctangent x when x equals to 0 is 0. X squared over 1 plus x squared at 0 is 0. Plus the last term, when we are plugging x equals to 0, exponential term is 1. We'll get y0 is 2 plus 0 times y prime at 0. Okay, so what is the derivative of y? From this equation, can you solve and find y prime 0?
It's negative
Minus 1 over 6.
Minus 1 over 6. Okay.
Cancels out and remains, yes.
Okay. Hence, let me write the equation of tangent line here. The tangent line is given by y equals to negative 1 over 6 times x minus x0, x, plus value of our function is 2. This is the equation of tangent line, right? Even, once again, if equation is given implicitly, we can still find the equation of tangent line by finding value of our function, plugging given x into our equation, and taking derivative. Here, the only challenge is that keeping our mind that y is a function of x. So we should treat y as a function of x.
I have
Questions?
a question regarding this one, may I?
Please go ahead.
So every time we see y in our differentiated equation, we should write x in parentheses next to it to not
Yeah,
confuse it.
exactly. You can write x to point out that y is a function of x, and that will help you within the calculation.
Um,
That it's a
I
function
was
of x. This is not variable, it's a function.
I was just wondering if we don't write, will it be considered not?
No, that's fine. It's up to you. Like in our equation, y is written without x. Okay, we have y cubed and not y cubed x. I just wrote x to point out to stress that y is a function of x, but you can skip all these brackets and x inside. That's fine.
Okay, thank you.
Okay. Move forward to the third exercise of the same year. Calculate the limit. Okay, let's think of what? Plug 0. If we plug 0, we'll get 0 divided by 0, right? Since 0 divided by 0 is an indeterminate form, we can apply L'Hopital rule. Am I right?
Yes.
So we have two options. From the beginning, apply L'Hopital rule, which is fine, but sometimes applying some useful limits can help us with the calculations. In particular, we have here sinus 2x factor. And what if this sinus 2x, we just multiply and divide by 2x, then later on we'll use that useful limit. So I would, once again, from the beginning, applying L'Hopital rule is fine, but I will do separately. I will write x tends to 0 and 2x divided by sinus 2x multiplied with sinus 5x plus sinus 3x minus 8x divided by 2x cubed. So we just multiplied and divided by 2x. And now focus only on this part. Let's just consider this term and calculate the limit of it separately. Limit x goes to 0. Sinus 5x plus sine 3x minus 8x divided by 2x cubed. And if we plug 0, we have 0 over 0. Hence, we can apply L'Hopital rule. And L'Hopital rule says that limit of f over g is the same as limit of f prime over g prime if you have indeterminate form. What is the derivative of sinus 5x?
Cosine 5x.
Cosine x. 5 cosine x. 5 cosine 5x.
5 cosine 5x. Derivative of sine 3x. 3 cosine 3x. Derivative of 8x is just 8. Yeah? And divided by 6x squared. Right? And then we can again plug 0. If we do so, we'll get 5 plus 3 minus 8. So 0 over 0 again. Okay, do not worry. We can simply apply another L'Hopital here, since it's indeterminate form of 0 over 0 form. So limit x tends to 0. What is the derivative of 5 cosine 5x?
Negative 25 sine 5x.
And similarly, we have negative 9 sine 3x divided by 12x. Here, you can again plug 0, C 0 over 0, and do once more L'Hopital, or alternatively, we can apply useful limits. Let's do useful limits. Split into two parts. We have limit x tends to 0. So minus, we have 25 times sine 5x would be nice if we divide it by 5x. Okay, we can do it, but we'll have to multiply by 5. Numerator and denominator, we'll get 125 over 12. This is just the first part of our expression. Similarly, we'll get minus 27 over 12 sinus 3x over 3x. And the limit here finally gives minus 125 over 12, because useful limit says this is 1 and this also is 1. Hence, combining this, we'll get minus 152 divided by 12. Okay, going back into our initial exercise. Yes, the limit is, since 2x over sinus 2x again tends to 1. So this tends to 1 and this tends to minus. Can we simplify? Can we divide by 4? If we do, we'll get 38 divided by 3. So the limit is minus 38 over 3. Is this okay? Questions?
I have one question.
Go ahead.
While trying to combine L'Hopital with the usage of useful limits, we aren't allowed, right, to pass to the limit at the I mean, we can't pass to the limit without entirely passing to the limit if we.
Very good remark. Very good remark. Guys, please do not pass to the limit partially. Like if you have your whole expression and it composed with different, maybe useful limits, maybe more complicated limit, do not pass to the limit separately. When x tends to 0, either everywhere pass to the limit and get the answer, or do not pass to the limit. Like here, if from the beginning you write this 2x over sinus 2x tends to 1, so drop this term, do not write like this. Yeah, it can be correct. It is correct actually in this case, but sometimes it is wrong and we cannot, maybe we can miss here easily by passing to limit. So much better too, if you have big expression, a bit down, a bit below, calculate limits of each of the components that you have on your big expression, and then like we did here, combine everything into your to get your final limit. Yeah, do not pass to the limit partially. Do it once and 10x to 0 and get the final result at the end. In between, you can like consider separate components of your big expression. That's fine. Other questions? Okay. 2021 show work 1 and 3 done. Let's go back to multiple choice number 6 of this year. Function f is continuous on closed interval 0 to 2. It's given that f0 is minus 2, f2 is 2, derivative is strictly positive, and double derivative is strictly negative. What can we say about f1? Okay, let's think together. So our goal is now to translate given information into something about f and f1 in particular. So first thing that we will use here, that f prime is 0. If f prime is greater than 0, this means that our function is increasing, strictly increasing from 0 to 2. So f is strictly increasing on our 0 to 2 interval, which means that f at 1 is going to be greater than minus 1. f1 is strictly greater than f0. Right? And also it is strictly smaller than f2. This is being strictly increasing. Hence, f1 is greater than minus 1 and smaller than 2. Let's drop all answers that are smaller than minus 1. Unfortunately, we do not have such answer. And also drop all options that are greater than 2. this one. And also we are dropping deep since we have strictly increasing function. Questions here? Okay. Then it remains three possibilities, 0, 1/2, and 1. What can we do? So far, we just used the fact that function f is increasing, but also f double derivative as strictly negative. What can we get from that? If second order derivative is negative, that means our function is concave down. Concave down means that f alpha x plus 1 minus alpha y is greater than alpha f of x plus 1 minus alpha fy, which is true for any x and y, and alpha from 0 to 1. Now, suggest me choice alpha and x and y, which will be useful in the framework of this exercise. What can we choose instead of x, y, alpha to get something about f1, f0, f2? Asik, help me. Interesting. X, y, and alpha. Now, we have here something about f of x and f of y. And we have to choose x, y in a way to get something that we know. In particular, we know that f0 is -1. We know that fy, when y equals to 2, is something. So let's choose x is 0, y is 2. If we do so, we'll get f alpha x, alpha times 0, then 1 minus alpha times 2 is strictly greater than some alpha times f0. So alpha times f0, f0 is -1. Plus 1 minus alpha times 2. Okay. What we should choose as alpha to get, remember our goal is to understand what is f1. So alpha, let's choose 1/2 to get something about f1. If alpha is 1/2, we'll get 1 minus 1/2 here. F at 1 should be greater than 1/2, which means 0 and 1/2 should be eliminated. And it remains only f can be 1. So the main point of this exercise was to use the concave down, definition of concave down functions, and choose x, y 0 to 2, and alpha is 1/2 to get information about f1. f1 should be greater than 1/2. Okay, f1 greater than 1/2. The only potential answer here is C. Questions? No question. We can move. Do we have any other question from 2021? No. So the next questions are from 2019. Multiple choice 7 and 8. F has removable discontinuity point. Removable discontinuity point at 1. Jump discontinuity point at 2. And essential discontinuity point at 3. Which of the following should be true? Removable discontinuity point means that function actually has limit at point 1. Limit when x approaches to 1 of our function f of x exists. So limit from right and left are equal to each other, but it's different from value at 1. Now, if we multiply f of x by x, let's say limit is 1, but value is b, and a and b are different. Guys, what do you think? What is the limit of f of x times x when x tends to 1?
Isn't it
X?
the limit of x times limit of fx?
Yes, and limit of f of x is a, limit of x is 1. So fx times x again tends to a. Because x tends to 1, this product of x has no any impact. What is the value of this function at 1? If this is our gx, what is g1? It is f1 times 1, right? G1 is again f1. It's again b, and a and b are not equal to each other. So we can say for sure x times f of x again has removable discontinuity, not jump, but removable discontinuity, because limit exists. So a is wrong, because to get removable discontinuity, we have to get some limit from right side, finite number, but different from the limit of our function from the left side. Now let's discuss statement B. What do we know about function f at 2? That it has limits from right and left, but different limits. From left side, our function has some limit. Let's say limit is a, and limit from the right side exists is another finite number b, but since we have jump discontinuity, a and b are different. Now, if x minus 2 f of x is our g of x function, what do you think what is the limit of g at 2 from left side and from right side? X minus 2 times f of x.
0.
From left or from right? From left or from right is 0.
I guess from both sides.
From both sides, I agree, because we'll get 0 times a is a constant. 0 times a is 0. And from the right side, it is 0 times b, again 0. So limit of our function from right and left are equal. Can we say function f is continuous?
At points 2, yes.
Just if limit from right equal to limit from left, function is continuous? Is this enough to say function is
It
continuous?
also should be equal to the f at that point. F
Okay.
limits at that point.
At that point, so we are talking about function g, which is x minus 2 times f of x. What is g2? G2 is 2 minus 2 times f of 2. F of 2 is some constant. So it is 0. Limit of our function from left is 0, from right is 0. The value of our function at 2 also is 0. Can we say it is continuous?
Yes.
It seems we found the correct answer. But let's discuss the rest. What is the difference between B and C? Between B and C, the only difference is that now we have essential discontinuity. And essential discontinuity means that function at 3 might explode. Maybe limit is infinity. Now, what is the limit of x minus 3 times f of x if x tends to 3? Say from right or from left. Maybe f tends to infinity. And
It's indeterminate form.
right, and maybe we have 0 times infinity, which can be anything, which can be infinity even. So maybe we have still an essential discontinuity. Maybe not. Maybe not. So, which means both C and D we should drop because maybe our function is not tending to infinity fast enough to get limit infinity. Maybe it's not essential discontinuity is finite or not, so we do not have enough information to see that for sure C is correct or for sure D is correct. Maybe for some cases C is correct, for some cases D is correct. So we are eliminating the last one, these two answers. And for the last one, we have 0.x times fx plus 2. Do we have here jump discontinuity? To get jump discontinuity, we have to calculate limit from both sides. Say x tends to 0 from the left side, x times fx plus 2. When x tends to 0, x plus 2 tends to 2. At point 2, our function has jump discontinuity, which means it has from left some finite limit, from right some finite limit. And finite limit times x, what is this limit? When x tends to 0, what is the limit of
0.
0.
What is the limit from the other side, from the right side?
Again 0.
So can we say that statement E is wrong? Because if limit from both sides are equal, then even if it is a discontinuity point, it is not jump. But actually, in this case, we have a continuity point. Huh? Okay, so the correct answer is B. Questions? Okay. This was 7, and the next one. We saw already graph like this. But now we are given graph of function f. This is graph of f. Which of the following is the graph of the derivative? Guys, here, the way of thinking is the following. Let's try to eliminate wrong statements. So how we can eliminate? Let's, from this A, B, C, D, find some patterns and discuss which statement for sure like is wrong or correct. For example, before 0 point, on some graphs, like when x is like here, derivative should be positive or negative. What's going on here? Our function f is decreasing, right? So do you agree that fx is decreasing from some minus delta to 0? On the left side of 0, function is decreasing. If function is decreasing, that means our derivative should be negative. So statement B cannot be correct because here derivative is positive. It should be negative. So statement B we can drop from the beginning. So we are eliminating this. What else? What else we can see? For example, we can see that on graph of C, derivative at 0 is not 0. For A and B, derivative passes through the origin, which is not the case for graph number C. And at 0 point, we have actually here an extrema point. Extrema point should be a critical point, right? Derivative should be 0. Not the case here. So we can eliminate statement C. Love? Now compare A and D and find some difference between these two graphs. Give me some difference between A and D.
The tangent line.
Tangent line where?
This line.
Yeah,
On the left.
not tangent, just line. This line
Okay.
near A is a bit different. So, in particular, in the right side of point A, derivative is negative or positive? What should be true? On starting from A, our function is increasing or decreasing? F
Decreasing.
decreasing. If A decreases after A, so derivative should be negative. It can't be like this. It can't be positive. Hence, this also should be eliminated. And we left with only one statement, which is not true. We do not have only one statement left. We have none of the above also here as potential right answer, but A is correct statement, which is a tricky part, but all properties that we can get for the derivative of our function here preserved, like sign of derivative, critical points, at point where derivative doesn't exist, this king point derivative doesn't exist, look here. So all concavity, etc., everything is preserved in statement in graph of A. So statement, the graph of A is actually indeed derivative of f. The rest B, C, D we have eliminated easily. The tricky part is A is correct or none of the above is correct. Do you see why this can be a tricky? For example, who says that derivative maybe here is increasing much higher than in our graph, but it kanker is a kancheng. Huh? So A is the correct answer. Questions? Taas liinat tavakan. Scoulish Hearts. 22. Okay. Multiple choices, 5, 6, and 9. All right, 22, 5, 6, and okay, guys, we'll not consider this now. It's about integrals, substitution, which is not a part of this coverage material, so I'm not going to discuss it now. Remind me to talk about this example during the review for the final exam. It's not relevant for this test. But the sixth one, yes, let's discuss. So we are given function f, which is continuous differentiable. F prime is strictly positive, so function is increasing. Double derivative strictly negative function is concave down. Which table could represent points of f? Okay. Let's think. Function increasing. Do we have here some decreasing functions?
E.
E decreases. Okay. Can be correct. Say again.
Also D.
D eliminated as well. It remains only A, B, C. And yeah, A, B, and C all are increasing. So let's now think about concave down functions. Concave down once again means that f alpha x plus 1 minus alpha y is greater than alpha f of x plus 1 minus alpha f of y. Let's begin with statement A. In Channing, let's choose x is 0, y is 1, and alpha is 1/2. When alpha equals to 1/2, we'll get alpha x plus 1 minus alpha y will be f1. Is f1 greater than f0 plus f2/2? So concave down function satisfies this inequality. First function given on table A. f0 is 10, f2 is 15, 10 plus 15, 25. 25 divided by 2, is it smaller than f1? No, it is greater than 12. So A can't be true. Let's discuss B and C. For BC, 10 plus 14, 24 divided by 2. Is this smaller than 12? It equals. So B also should be eliminated. And only for statement C that is correct. 10 plus 24, 34 divided by 2 is 17. 17 less than 18. Yes, there is no any contradiction. And we can actually change x, y, not choosing only 0 to 2. We can choose 1 and 3. And middle point should be strictly greater than f0 plus f1 plus f3 over 2. But in this case, we left with only this. one approach to solve this exercise, guys, which I do not like graphically, and it will be even like very hard for me to draw the graphs here, but you can somehow, like, we have 10, 12, 10, we have 0, 1, 2, 3, and 4, and try to put points correctly. And then see whether you are going to get concave down or not. But you can use the definition as we did, and it is maybe better. Questions about this exercise? If not, it's a 9. Okay. Function f, differentiable function, derivative strictly positive, and we are given inverse of function f. Which of the following statements is true in general? Function f is concave up. Can we say if derivative is positive, function is concave up?
No, it maybe could be concave down.
Right. We know that function is increasing. Who says it should be concave? Derivative fx equals to 0 has exactly one solution. Is this true? Can we say if we have strictly increasing function, it has exactly one solution?
Maybe it doesn't cross the x-axis.
If it is increasing, we can say at most, maximum, we have one solution. Maybe no solution to this equation. Okay.
Is getem gunenang f prime havasarasroi tachkarenkosen tejum.
Asta havasarnes. Always.
As the equation f prime is equal to 0 has exactly one solution.
It has no solution because f prime, it is given to be strictly positive. F prime is positive. It cannot be equal to 0. F prime is positive. Here we know that f prime is positive. It cannot be 0. So that equation has no solution. C, D, and E are about derivative of inverse functions. What says formula of derivative of inverse functions? It says that derivative of inverse function at point y0 is 1 over f prime at x0. Now, since we have here derivative at 0, we can say f inverse function derivative at 0 is 1 over f prime at, again, some point x0. We do not know whether this x0 is 0 point or not. We don't know. Now, can you say which of the remaining 3 statements, C, D, or E, is the correct statement? Can we say that, okay, what is x0? x0 is a point where fx0 is 0. And we do not know whether x0 is 0 or not. If x0 is 0 point, then this is correct answer, because multiplying this by f prime, x0 will get 1. But once again, in this case, multiplying this by f prime 0, is it going to be 1? Who says that f prime 0 is the same as f prime x0? Maybe x0 is different. So this is not correct. About sum, f prime 0 plus 1 over f prime x0 is 0. Why it should be 0? There is not any information about function f. Can we say inverse is increasing? Yes, we can, because f prime is positive. So is 1 over f prime. 1 over f prime is strictly positive, so inverse function is always increasing. Derivative of inverse function is always positive. Inverse function is increasing, strictly increasing function. So we have this, the correct answer. Questions? If no, again, let's move forward and go to the test 2024. Multiple choices 7, 8, 9, and 10. We have function f. At 1 is 4. Limit from right and left are 1 and 3. Which of the following function has removable discontinuity point? Removable discontinuity point means it has limit, which means limit from right side equal to the limit from left side. But the value of our function is different. Let's do the calculations for, let's begin with A. What can we say about limit from right side? Let's write this. Gx. Gx is this fx minus 2 cubed. What is the limit from right side? From the right side, f tends to 1. Okay? We'll get 1 minus 2 minus 1 cubed. So minus 1. What is the limit of the same function from the left side?
1.
It's 1. Okay. So we can say definitely function g at point 1 has jump discontinuity point, not removable. Moving forward, what can we say about statement number B?
It's essential discontinuity.
It's essential discontinuity due to this fact. F tends to 3 from the left side. So we'll get 4 over 0. Same, we can drop C because at 1, it has again essential discontinuity. Okay, because limit from right side at 1 is 1. We will get 1 over 1 minus 1. 1 over 0, infinity. And we have now D or E remaining. Let's calculate limits. X tends to 1 from right side of g of x. From 1, we will numerator.
On both sides, it's 0.
0.
1 minus 1, 0 over some constant. So yeah, from both sides. Can we say D is correct answer and move forward?
No, because function value is also 0.
Exactly. So even though limits from both sides are equal, but it is also equal to the value of our function. So D is continuous function. And it remains E. Should be correct answer this one, but let's check it. Let's check. Limit. So once again, now this is our gx. When we are considering limit at 1 from left side. Numerator is 1 minus 2 squared. As 1 divided by f from left side tends to 3. 2 minus 3 as 1. Huh? Same way, limit from right side of the same function g, again 1 over 2 minus 1, again 1. So yeah, from both sides we have the same value. But what is value of our g at point 1? If you plug 1, we'll get
1 over half.
1 over 2 minus 4, yeah, just 1/2. Huh? So this is enough to say our function g has removable discontinuity at point 1. Limit from right and left are equal to each other, but value of our function at 1 is different. So the correct answer is E. Questions? Next one. For which value of a f differentiable? Okay, given some parameter in this exercise, we have to just find a. Can you help me how we can solve this exercise?
We should use the definition of the
Definition.
Okay.
derivative.
Definition says that we have to consider limit. So we are talking about derivative at 0. So x tends to 0. F of x minus f0 divided by x. What is f0? 0 case is here.
1.
It's 1. So we'll get f of x minus 1 divided by x. We have to calculate this limit. And how we can find this limit? By considering sided limits from right side and from left side. Now, limit x approaches to 0 from, say, left side. On the left-hand side of 0 point, our function is defined as ax plus 1. So we'll get ax plus 1 minus 1 over x. And here limit is a. When x tends to 0 from the right side, we have root of 3x plus 1, still minus 1 divided by x. What is the limit of this expression? How we can find limit?
We can change places of 1 and 3x and then use a useful limit.
Okay. So you are suggesting to write it as 1 plus 3x to the power 1/2 minus 1 divided by 3x. If we have 3x
and times 3.
Times 3, so limit is what?
3 over 2.
Useful limit says this part tends to 1/2. If we do not remember useful limit, what can we do?
L'hôpital.
L'hôpital. Or in this case, maybe just multiply and divide by the conjugate of the numerator. Or another approach, if we do not remember useful limits, we can just open the last page of this test and find useful limits. 3/2 a, for which a function is differentiable? 3/2. Guys, do we need to check whether function is continuous?
If we already showed that the limit exists,
so it is
differentiable.
Yeah. So if fx minus fx0 divided x minus x0 has finite limit, it implies that function is continuous. In this particular case, for this function f, whatever is value of a is given, it is continuous, because limit when x tends to 0 from both sides is 1. So f is continuous for any value a you wish. but it is differentiable only when a is 3/2. Okay. F be strictly monotonic, differentiable function. H is the inverse of f. Given table for some values of function f. Determine the maximum value of hx. Okay. Minutes ago, we said if f, so f is monotonic. Now question, f is increasing or decreasing function? Is
Increasing.
obviously f is increasing. Do you agree that f minus 1 also is increasing?
Yes.
We said that the derivative of this inverse function is 1 over f prime, ensures yx difference, but it is positive. Now we have hx increasing. What is its maximum value on 0 to 10 interval?
Aren't the values swapped when we consider the inverse of the function?
Yes, you are right. But first, what I'm asking, what is the maximum point of our function h?
Maximum point is 10.
It's 10, right. Now, what is h10?
12.
Uh-uh.
8.
It's 8.
H10 8.
Yes. So as you said, guys, the same table we can use for inverse function, but now hx is this, and inputs, or let me write hy here and y here. So value at 10 is 8. H is the correct answer. Mi vaikam, vai stāstīt, kas ir jāved limits?
At inversity.
Inversity, right. The 12 is the maximum value of our function, but inverse function h from 0 to 10. So inputs for inverse should be from 0 to 10. So we have to just focus on this part. And inputs for our inverse, from 0 to 10. Outputs are from 2 to 8. For the same function, guys, what is the minimum possible value of our, so let's imagine this maximum is replaced with minimum. What is the minimum value of h on 0 to 10 interval? Inch kasek.
2.
2, right. Minimum is at 2, and the 2 value is, is 2. Minimum is at 0, and inverse at 0 is 2. Okay. Number 10. F, G are continuous on 0 to 3. Differentiable and open set. So only this part of exercise says we are most probably going to apply mean value theorem or Rolle's theorem. Let's continue. F1 equals to G1. Yeah. And it's quite similar to Rolle's theorem. F prime is strictly less than G prime for any x from 0 to 3. Okay, which of the following is false? Which of the following statement is definitely false? Okay. Guys, first of all, let me just introduce function h of x, which is g minus f. What can we say about h function, guys?
It's always. Oh.
It's always inch. Always
People say it's always greater than 0, but the derivatives of f and
Okay,
Yeah.
derivative is always strictly positive. So what is h?
it's always increasing.
It is increasing, even strictly increasing. What can we say further about function h?
That at point 1 it's 0.
h1 is 0. So we have increasing function at 1 is 0. Can we say h at 0 should be negative? Because it's increasing. At 1 is 0, so before 1 it should be negative. Increasing function at 1 reaches 0. So we can say before 0.1 it is negative. And after 1 it is positive. So hx is positive if x is greater than 1, and hx is negative if x is smaller than 1. This is just consequence of being increasing function. Hima, f0 is less than g0. Remember, our function h is gx minus f of x. At 0 point, function is what can we say about 0 point? It should be x is 0 negative.
It
so
should be equal.
Here we should have equality. No, it's if I can. Like, what is h0? Do you agree that h0 should be negative? Because at 1 it is 0, before that point it should be negative. h0 is g0 minus f0 should be negative. Hence, g0 should be smaller than f0. This statement seems to be false. But let's continue reading our next statements. Statement B says g2 is greater than f2, or the translation of this is h2 is positive. Yeah, h2 is positive. Statement is true, so we cannot choose this answer. If function f increases, then g also increases. If function f increases, then function g increases. Best thing. Do you agree if f is increasing, then f prime here is positive? And g prime also is positive. F increasing implies g increasing. Yes, it is true. So we are dropping this answer. G decreasing, f decreasing. Again, here it's very simple to see that this statement is true. If f prime is less than g prime, and g is decreasing, so derivative is non-positive, f prime also is non-positive. Statement is true, so we should drop it. The last one says fx equals to gx has exactly one solution. And this statement also is true. Why so? Minutes ago, I introduced hx. Hx actually is gx minus f of x. Now we are thinking of zeros of function h. How many zeros we have for h? We have it is increasing. Increasing means it has maximum 1 0, at most 1 0. And at point 1 it is 0. We know it's given. So we have exactly that 0. And from the beginning we said that this is wrong. So yeah, here we go. Questions? We have show work number 1 from this test.
Which year's midterm is this?
2024.
Thank you.
Look, we have 2 versions of this test, 2024. This test was uploaded days ago, and today we have uploaded the second version. But I think that questions are from the old uploaded version. So I hope the questions are from this. Like, if it is not, then correct me. Find values of a and b for which function f is continuous, and to check continuity of function, we have to consider sided limits. To get continuous function, we have to consider limits from sides, in particularly left-hand side of -1 of f of x is limit e times ex minus 1 divided by x plus 1. X tends to -1. Okay, how we can find this limit, guys? If we plug -1, just plug -1, we'll get 0 over 0, so indeterminate form. Inçaning, Monsaşving.
We can represent e times e to the x power in the form of e to the x plus 1 power.
Okay.
And x plus 1 tends to 0.
Useful limit.
Useful limit.
Okay. Another approach, it's fine. Let's do like that. Another approach is L'Hopital. E x plus 1 minus 1 over x plus 1. As x plus 1 tends to 0, actually we can use that, just useful limit. Limit is 1. Right? E to the power of t minus 1 over t tends to 1. We use this useful limit. Instead of t, we have x plus 1. But x plus 1 tends to 0, so we can use it. It's true as t goes to 0. Okay, done. Limit from the right side of the same function. X goes to 1 from the right side. Sorry, we have -1. -1, but right side. -1 right side is just ax plus b. What is the limit of ax plus b at -1?
1 again. It should be.
In G. It should be 1, right? Right. But limit of ax plus b is just plug instead of x minus 1, we'll get b minus a. Or to get continuity here, the first information that I will be sorry, let me erase this part. Yeah. It's b minus a. Limit from right side should be equal to the limit from left side. And actually, yeah, this is the same as f minus 1. Obviously, f minus 1 is again b minus a. Okay, this is our value at -1. So we have one information that our b is a plus 1. What else we can say? We can consider now limit of our function from right and left at point 2. And let's see what happens here. Okay, so limit at 2 from left and right. From left, we have still ax plus b. And at point 2, limit is 2a plus b. And right side is x squared minus 5x plus 6 divided by x minus 2. If we plug 2, we'll get 4 minus 10 plus 6, 0 over 0. How we can find this limit?
L'Hopital.
Okay, what else? L'Hopital will work. That's
We
fine.
can represent
We
the
can
number
just divide by.
vectors.
Okay. Our actually numerator is x minus 2 times x minus 3. So x squared minus 5x plus 6 is x minus 2 multiplied with x minus 3. We have two roots, 2 and 3. So here we'll get minus 1. Now we have to choose a and b such that b minus a is 1 and 2a plus b is negative 1. B is a plus b, a plus 1, and plug b a plus 1, we'll get 3a is minus 2, so a is minus 2 over 3, and b is 1/3. B is 1 plus this, so 1/3. Questions? Okay, so the last questions are from test from 2023. Yeah, we have questions number 4 and 6. Function f, bitwise differentiable function. At minus infinity, derivative tends to 1. At plus infinity, derivative tends to 2. F prime is increasing. Which of the following statements is true? Okay. Now, f prime at minus infinity is 1, at plus infinity is 2. It is increasing. Do you agree that range of f prime is Kasekishna? What are values of f prime?
1 to 2.
Open or closed?
Closed.
Closed, you mean it achieves 2 and 1. Ինչ որ կետում կա, որ արժեքը 2-ա. Limited plus infinity.
No, it's approaching to 2.
It's approaching to 2. So range. So any value from 1 to 2 is achieved by our function. Okay. What else can we grab from this information? F prime and f function is concave up, right? Derivative increasing, f is concave up. F is concave up. Okay, let's see what can we say. Concave up, the definition. So I'm just thinking about C and D statements. These are similar to concavities. Concave up, f alpha x plus 1 minus alpha y is smaller or equal than alpha f of x plus 1 minus alpha fy. Now, if we choose alpha 1/2, when alpha equals to 1/2, concave up implies that fx plus y half is smaller than or equal to fx plus fy half. Here we have not the same sign of inequality, so this is not true. And actually for statement D, we can do the same stuff, but choosing alpha 1/3. Again, choosing alpha 1/3, we can drop D, we'll get actually here the other sign. Huh? Now we have A and E that look similarly. Let's now consider statement A and E. Okay. In Chinamana, in.
Mean value theorem.
Okay, let's try it. Maybe value theorem says that f3x minus f3y divided by 3x f3x minus f3y divided by 3x minus 3y, like this, is derivative at some point C, where C belongs to 3x to 3y interval. And module equals to the module of f prime. Okay. What do we know about f prime? Remember, we just discussed that f prime is greater than 1 and smaller than 2. Right? So it is smaller than 2. And multiplying by 3x minus y, bringing to right side, we'll see that actually, yes, this is correct. And y, I scrolled up a bit, y e is wrong. Because if we try to do same with f2x and f2y, f2x minus f2y divided by 2x minus y is f prime at some point C. So module equals to module f prime. Since here we have greater sign, we can say derivative is always greater than 1. Okay? It's from 1 to 2. And bringing 2x minus y to the right-hand side, instead of this 4, we have 2. We don't know whether it is true for 4. When we have, what we can say that definitely module f2x minus f2y is greater than or equal to 2 times x minus y. Yeah, this is true. But with 4, we don't know if it's true or not. And since what says statement B? The graph of function f is below the graph of the tangent line. And now, please pay your attention. If we have concave up function, we have concave up function. Do you agree that tangent line is always I'm trying to draw a line here. Here we go. This is tangent line. And graph of our function is above the graph of tangent line, not below. It should be above. If you have concave up function, then our function is above the graph of tangent line. If you have concave down, then concave down, yes. Yes, in this case, graph is below the graph of tangent line. Huh? So A is the correct answer.
Can I ask a question?
Sure.
For A, if we say that range of fx is from 1 to f derivative is from 1 to 2
Yeah.
open interval, can we say that it is smaller or equal part? I mean,
Yeah,
is
but
it true?
look, if we can say that f3x minus f3y is strictly less than 6 times x minus y. If this is true, can we say also A is true?
Yes.
Yes, because he, okay, even if equality doesn't hold, still, we can say that this is true.
Okay,
Huh?
thank you.
Okay, and the last question, number 6. We are given a table for function f. And function f is continuous differentiable. How many of the following statement conditions must be true? Okay, function is continuous and differentiable. And we know that f0 is 2, 2, f2, 4, 7, 10, 8, and 2. How many should be true? The first statement, f is positive. Is this true statement, guys?
No.
No?
Yes, it is. I'm sorry.
It's not true. Okay, it's not true because we don't know what's going on in between 0 and 2. Maybe function from 2 decreases to minus 96 and then jumps to 4. We do not have enough information what's happening in between of these two at these points. Okay, continuous, fine. Differentiable, fine. But still function can go below to the axis and jump, etc. F prime at 6 is 0. Can we say that this point 10 is our local maximum? Is this local maximum?
Yes.
Like 10 is greater than 7. Okay, greater than 8. But how do we know that? Imagine this is point 3. Here we have 6, and here we have 8. At 3 we have 7. It increases. It continues to increase and then decreases. Maybe maximum point is not 6, but it's 7. We don't know. So we cannot say that this is also true. Maybe our maximum is at 0.7. Huh?
But if our derivative is 0,
How we can prove that derivative is 0 just using this table? This table is not enough.
it just says that it's 0, and I thought that it is given and we should decide
No.
with the 6s.
Yeah,
maximum.
it's not given. Is this true or not? No, it's not true. F prime at 3, here should be positive. Again, we don't know. Maybe starting from 2, our function increases and then starts to decrease and then again increase. And at 0.3, it is decreasing, not increasing. So this is not guaranteed that f prime 3 should be positive. Just this table is not enough. For some value of x on interval fx equals to 6. Okay, let's discuss fourth statement. Should it be true?
Yes.
In between 2 and 4?
See,
Say again, why it should be true? So here we have,
because it goes to from 4 to 7, so it must
Okay.
also be 6 between.
yeah, and according to which theorem?
Intermediate value
Yes.
theorem.
Intermediate value theorem says that any value from, say, in this case, from 2 to 10, so from 2 to 10 is achievable by our function. Any value, in particular 6. So for sure, this statement is true. For some value of x, f prime should be 1. În ce mașină să? It seems now it's not intermediate value theorem anymore, because now we have some mean value theorem. Okay, what says mean value theorem? It says f prime at x is f b minus f a divided by b minus a. Now, please find a and b such that fb minus fa over b minus a is 1. If we can find a and b from 2 to 6 interval, then we are done. From 2 to 6. So just focus on 2 to 6 interval. For example, let's choose 2 is A and 6 is B. And let's see what's going on. FB is 10 minus 4 divided by 6 minus 2. As in stadswets. 10 minus 4 is 6 over 4. No, it's not 1. No, es mete celălalt.
If we choose 6 and 3,
6 and 3?
it will give 1.
Yes, you're right. Value 10 minus value 7 divided by 6 minus 3. Yes, it's 1. So this x actually not only belongs to 2 to 6. Actually, this x belongs to 3 to 6, as you said. So this is also true. Hence, we have only 2 correct statements in this exercise. Okay, guys. So we covered all your questions, but please keep working, and we'll have other opportunities to discuss. At least on Friday, we'll do a review session, and you can ask your questions during this session as well. And we are going to have office hours. Please use this time also to ask your questions. Ja?
Make a review session check on it.
Մենք վաղը մի քիչ դասկանենք, and maybe at the end we'll do some reviews. Let's see. Let's see what's... So I'm not sure you need 2 complete review sessions. If you have like questions, we can discuss your questions tomorrow as well. If no, let's do only Friday review. Okay? Okay, guys, so done for today. See you tomorrow.
Thank you.
Thank you.
Thank you.
you.
Thank you.
Bye-bye.
Goodbye.